Hi guys, this is Lucas. I'm. You guys remember my friend Luis? He did the project on acid rain. Well, he did the first part. He'll explain what it was basically and its effects. Well, I'm going to show you guys how to solve that. But first, I want to show you guys a video. Me and Luis, a week ago, we did an experiment at school. Basically, it involves making synthetic acid rain. Yes, synthetic acid rain. You heard that because we can't get sulfur and nitrogen to react with H2O form acid rain in a class. So the closest we could get was that. But check it out, it's fun, and if you guys pay attention, it shows like a quick overview of acid rain. So let's take a watch.
Sometimes when all that's lost remains, drink from the fountain of youth and never age again. Sometimes we jump across to every cloud, fly away, get lost and never be found. Sometimes when all that's lost remains, drink from the fountain of youth and never age again. Sometimes we jump across to every cloud, fly away, get lost and never be found.
Now, let's get back to the basics. You guys remember what acid rain is, right? Well, let me explain it. Well, acid rain is basically, it comes in two forms. It can either be formed from nitric acid or sulfuric acid. Now, we explained where to get the nitrogen and the oxygen for that experiment. Well, for that reaction. Well, let's go first. If you see up here, the nitrogen actually comes from our car engines. What happens in there is that nitrogen combines with oxygen to form nitrogen dioxide. And nitrogen dioxide itself isn't really the problem. What happens, it's the same thing with sulfur, is when it goes into the atmosphere and then reacts with H2O and it forms a strong acid we know as nitric acid. Now, what about sulfur? If you guys look up here, you'll see sulfur. It actually comes from burning fossil fuels because fossil fuels do contain a lot of sulfur. Um, so what happens is when we're burning that, it's going to see the same reaction. Sulfur is going to be burnt up. It's going to combine with oxygen to form sulfur dioxide, which, like I said again, not deadly by itself, but if you get it mixed with some water, well, you guys know you get sulfuric acid, which that you guys know is, by the name, is really strong. But enough of that. Do you guys know Louise was talking about those acid lakes, those dead lakes in Scandinavia? Well, guess what? Those were caused because in the 60s and 70s, there was actually no regulation for sulfur emissions. So what happened is power plants in Europe were burning out sulfur, and we didn't know much about it at that time. So they thought that sulfur would dilute. So basically, just remember this: they thought that dilution would be a solution. But turns out it wasn't a solution because what happens is that it floated in the air, did not dilute, formed a lot of acid rain, and the wind currents blew it to Sweden. Its natural wind currents blew it to Sweden. And it went to Sweden and fell into those lakes, and what happened was the pH levels dropped dramatically. And since that, it made the water literally toxic for the fish to breathe, and the lakes died. And what they had to do is, well, treat it with calcium oxide, lime, to restore the lakes. And that's actually one of the solutions. You can react sulfuric acid with lime and what will happen is it will basically neutralize the sulfuric acid. Well, what about other solutions for sulfuric acid? Well, a common one, if you look up here, is scrubbing. Well, what is scrubbing? Scrubbing is basically we're trapping it before it reaches the atmosphere. Now, what do you mean by trapping it? Well, this is complicated, so keep up with me. We trap it by using a mixture of salt water and of calcium oxide, lime. Well, what happens is that the sulfur is gonna react with the calcium oxide to form calcium sulfite. Here's the equation for it. Now calcium sulfite is gonna then react with oxygen to make calcium sulfate. Now calcium sulfate is actually harmless. Nothing will happen to it. And just remember, that process is called scrubbing. Now, something else. The sulfur also comes from our cars. Well, not our cars in particular, like the nitric acid, but from the gasoline we burn in our car. So we use a process called hydrosulfurization, which is basically combining the sulfur with hydrogen at extremely high temperatures and pressures, as you see the video next to me, to form hydrogen sulfide. Hydrogen sulfide is actually harmless, and that's where it gets dangerous because it's actually a very unstable gas, and it's a byproduct of some bacteria. Now, what about the nitric acid? Well, for the nitric acid, we use something called catalytic converters. If you see the little video behind me, catalytic converters, what they basically do is they get the nitrogen dioxide and they separate the nitrogen from the oxygen. When the nitrogen is separated from the oxygen, well, it's harmless. It's just nitrogen and oxygen. It would just flow in the atmosphere, and, well, nitrogen and oxygen are basic components of our atmosphere. So there won't really be a problem with it. Before we go, we're talking about all these effects. Me and Louise decided to go down to the Holocaust Memorial in Miami Beach and show you guys a quick video. We want to show you guys the effects. Remember, this was built in '65, so it's pretty old. And the effects that the acid rain has had on the statues is like really obvious. So I'm going to show it to you guys right now. Enjoy, and thanks for tuning into our vlog. To visually see the effect acid rain had on our environment, me and Louise decided to go to the famous Miami Holocaust Memorial in Miami Beach and see its effects. As you can see, most of these statues are quite faded and eroded, and the effect the acid rain has had on them is quite apparent. I mean, they've been standing there for more than 40 years.